In this lesson, we are going to apply the same methods using the normal distribution to find the probability that a student fails science. Okay, now failing science or failing anything, in most, especially the British system, is obtaining a grade less than 40. But in some places it's less than 50, whatever. Let's assume here, for the sake of argument, that it's less than 40. You get something less than 40, you fail. Okay, so remember the formula. We have to convert. All right, we have to convert from x to z using this formula. All right, so let's see how to do that. First, we need to find mu, x, and sigma. So I'm going back to my Excel sheet. For science, this row is science. The mean from last year, the population mean for science was 75. X will be the number I'm using here, so x will be 40. And the standard deviation last year was 9. Okay, so now we're going to do the translation. We have a normal distribution with a mean of 75 and the standard deviation of 9. Through the formula, x minus mu on sigma, we're going to translate it to a standard normal distribution. Standard normal distribution with mean 0 and sigma equals 1. Same as before, all right? The only thing that changes is this. My x was 40. So if this is my normal, 75 is the middle, 40 is here, all right? Probability less than 40, which we have here, means finding this blue area. But with the translation, 40 becomes something different. Let's work it out. So we're going to translate it. We're going to have 40. Sorry, let's keep using black. 40 minus 75 over 9. All right, quick journey to Excel. So let's have 40 minus 75 all over 9. All right, that's minus 3.89. Minus 3.89. So suddenly, from 40, I have minus 3.89. And my new blue region becomes this part. All right. As I promised you, I want to show you two techniques. All right. In the first part of the lesson, we used the tables. In this lesson, I want to show you how to do it using Excel. All right. So let's go to Excel. Let's stay in this Excel sheet. So the command is equals norm dist, because I am finding a probability. So it's norm dist. Now look there, what is the function tell me? I need to input x. So my x will be this number, minus 2.88. I need to input the mean. The mean, I am using a standard normal. So the mean is 0. I need to input the standard deviation. It's shaded in black. I am using standard normal. So standard deviation is 1. So that's a 1. And I'm going to say whether it is cumulative or not. In our case, we know that it's cumulative. The probability is accumulating from left to right, the blue region. So I'm going to put a 1 for true. 1 means true. It is cumulative. Close the bracket, enter. And as you can see, it's an extremely small number. 0.4 zeros and 5. All right, so probability that x is less than 40, which means failing, is equal to the probability that z is less than minus 3.89, which is equal to all of this stuff, 0.4 zeros and 5. And 5. All right. Here you might tell me, but wait a second. In science, we had a situation where we had a lot of failures in science. All right. How come we have such a small probability here? Right? And the reason is this. We have made the big assumption that our distribution for the entire population remained the same. Last year it was normal with a mean of 75 and a standard deviation of 9, and we are assuming that this year the distribution stayed the same. So I used the same numbers. But of course, you realize the risk in doing this because the distribution can fail, right? It can change, not fail, can change. What if we have a new teacher that is not doing his job well? What if we have a particularly difficult class this year? All right, so conclusion. When you make such an assumption that the whole population is staying the same, what we call stationarity, all right, you are taking a big risk. And that's why I use it for science here, because we had an answer that doesn't make sense. Later on, we will learn how to use information only from the sample and not from the population and the assumption the population is normal distribution. Okay, but the calculation here still makes sense. It is the answer which is a bit of a question mark. All right, in the next lesson we will go from the population to a sample.